Dear students, in today's session we will discuss about hypothesis test using t-test. Okay, this is our second video on t-test. Okay, now here we are going to discuss about one-tailed t-test. In last session we discussed about two-tailed t-test and two-tailed desert test. Okay, now we will be discussing about one-tailed t-test. Why I have taken this problem is, for one-tailed t-test there is a small difference which has to be noted very carefully, otherwise there is a chance of making mistake. Okay, now consider this particular problem. Given a sample mean of 83 and standard deviation of 12.5 and sample size of 22. Okay, so everything is given, that is x is given, sigma is given and n is also given. Okay, sample size of 22 and the test the hypothesis that the value of the population mean is 70 against the alternate hypothesis that it is more than 70. So use 0.05 significant level. Okay, so in this particular question everything is directly given in the question. We need not actually search for it. Okay, it is directly given. Now what is our null hypothesis? It's already given that mu is equal to 70. That is the null hypothesis. So we have to test the hypothesis that the value of population mean is 70. So H0 is given as mu is equal to 70. And what is alternate hypothesis or H1? Here we have to select alternate hypothesis that it is more than 70. Now you need not put it as not equal to 70 because already in the question they are telling that it should be more than 70. So mu greater than 70 is our alternate hypothesis. So from this we can understand that this is a one-tailed test. Okay, so one-tailed test means here you have, this is the t distribution and here only one tail we are considering. This is a mu value. So anything less than mu, that is absolutely fine, it will come in the acceptance region. But if you have a UCL here, this is our UCL. So anything going beyond this will only come in the rejection region. Anything below that, it's absolutely in the acceptance region. So this is called a one-tailed test wherein we are considering only one tail. Okay, now we can say this is a one-tailed test. Now we will go for the sample, what all is given in the question. Sample mean, that is x is equal to given as 83, then sigma is 12.5, n is 22, so definitely we know that it is a t-test because it is less than 30, and alpha value is given as 0.025. okay, this is where you need to be careful. Okay, now this is a one-tailed test. So actually in case of a t-test, in case of any t-test for that matter, look at this figure. This is a t distribution, right? This two tails combined, these two things are combined together, and that is what is the t value, correct? So t value is a combined area of two tails. So if it is a one tail test, you need to multiply the significant level by 2. Now when I say my significant level is 0.025, okay, when I say it is 0.025, that means this two part, that is these two areas are together giving us 0.025. Fine. So here whenever I am going for a one tail test, that is this one I am not considering, I am considering only one part, then I will have to multiply the significant level by 2. So my new alpha value will be 0.025 into 2, which will give me 0.05. okay, so I need to calculate my t value considering this particular alpha. That is the difference between two-tailed test and one-tailed test. I hope that is clear to you. Now we will solve the problem. Okay, so all the things are given in the, whatever is given in the question we have written down. Now we need to calculate the standard error. Standard error or sigma x is calculated using the formula sigma by root over of n. Why? Because the population size is unknown to us. We have only the sample size and standard deviation. So standard deviation given in the question is 12.5 and n value is 22. So on calculation you will get the standard error or sigma x as 2.66. Okay, so you have calculated the standard error. The next thing that we need to find out is the t value. So how we will find t value? So before finding out t value, we need to know what is the degree of freedom. Okay, so it is given that the sample size is 22. So what will be degree of freedom? Degree of freedom equal to n minus 1, that is 22 minus 1, which is equal to 21. This is our degree of freedom. So now we need to calculate the t value of 0.05, that is the significant level, under 21 degrees of freedom. That you can get it from the table. So on looking to the table, for 0.05 under 21 degrees of freedom, you will get the t value as 1.720. This is the table value. That is, this table is available in the back side of the logbook. Fine. So this is the table value. Now you have t value, you have standard error. So how you will calculate UCL? Now we need to calculate only UCL. Why we are finding only UCL? Because it's already given in the question that if the alternate hypothesis is mu greater than 70, so we need to check only one thing. Fine. So you need to find only the UCL value. Now UCL is given by the formula mu plus t into sigma x. So what is mu? Mu is equal to 70 plus t is 1.720 into sigma x. Sigma x value is 2.66. Okay. So on calculation, you will get the UCL value as 74.57. This is your UCL value. Okay. So now this is the UCL value, that is 74.57. Now check what is the x value, that is sample mean value is 83. Okay, so when you are depicting this, that is, it is in the diagram. When you draw the diagram, you can see that, okay, the mean value, that is 70 is here, and the UCL value is 74.57. okay. So this is the rejection region. Definitely 83 is going to come somewhere here, that is in the rejection region, right? So we can say that since the sample mean is greater than the UCL value, we are rejecting the null hypothesis. Okay. So finally you can write the inference like this: since sample mean, that is x is equal to 83, is greater than UCL, we reject the null hypothesis, therefore population mean is greater than 70. So I hope this is clear to you. When it comes to one sample, one tailed t-test, only thing that you have to notice, this t value gives the combined area of the two tails. So if it is one tail test, multiply the significant level by 2. That is the only difference. All the remaining things remains the same. Okay. Thank you, students.